Hi everyone, this is question number 32 in chapter 2. So solve the following problems related to the small changes in approximation. So this is the application of differentiation whereby we involve the del y by del x approximately equivalent to dy by dx. Okay, so given that y equals 2x cubed minus 5x squared plus x minus 1, we have to find the value of dy dx when x equals to 1. So let's find that first. So part A, so dy by dx equivalent to, bring down the power 3 to multiply with the term. So we have 6x squared minus 10x plus 1. Okay, so when x equals to 1, the value of dy by dx will be 6 minus 10 plus 1. So over here, we will have negative 3. All right, hence, find the small changes in y. Now, small changes in y in terms of symbol is delta y. When x increases from 1 to 1.02. So when x from 1 increases to 1.02, there is a very small changes in terms of x, so delta x equivalent to 0.02. The difference is 0.02. So now we need to find the del y. Okay, so we use the relationship between the delta y by delta x and the dy by dx. Okay, delta y by delta x equivalent, approximately equivalent to dy by dx. So to find delta y, approximately equivalent to dy by dx times with delta x. And that equals to, so dy dx we already found, that is negative 3. And then the delta x is 0.02. Therefore, the delta y will be negative 0.06. That shows that as x increases from 1 to 1.02, y will reduce about negative, will reduce 0.06 in terms of the value. Okay, that's it for part A. Now let us move on to part B. So in part B, we are given the curve. Okay, we are given the curve and find in terms of p. Okay, where does this p come from? Yeah, where p is a small value. Okay, p is a small value. So we have to find in terms of p the approximate change in y when x increases from 3 to 3 plus p. Okay, let's get the curve first. So y equals to 9, 2x minus 5 raised up to the power of negative 2. Okay, and then we got to find the approximate change. So we got to find delta y when x increases from 3 to 3 plus p. That means there is a very small changes in x, which is p. So we shall use this one. Therefore, let's find the dy dx first. So dy by dx equivalent to negative 18, and then do outside. Okay, then followed by do inside 2. So let's combine the negative 18 and 2. So we have negative 36 over 2x minus 5 raised up to the power of 3. That is dy dx. And therefore, to find delta y by delta x approximately equivalent to dy dx. So the delta y approximately equivalent to dy dx times with delta x. So what is dy dx? It's negative 36 over, now this must be based on the initial coordinates. So the x coordinates is 3. So we shall replace x with 3. So we have 2 times 3 minus 5. Everything raised up to the power of 3. And then times with our delta x. Delta x is p here. So we have negative 36p over 6 minus 5. That is 1. So 1 cubed is still 1. So the answer is negative 36p. So the changes in y is equivalent to negative 36p. Okay, now let us move on to part 2. So part 2, we got to find the approximate change in x. Okay. When y decreases from 1 to 1 minus p. So delta x is the one that we need to find. When y decreases, that means initially is 1 and then change to 1 minus p. So from here, we can find delta y, which is negative p, because negative shows that it is decreasing in value. So, well, we use this delta y by delta x, approximately equivalent to dy by dx. Now, the question is, our dy dx is in terms of x. So is it possible for us to find the corresponding x value when y equals to 1? So let's do this. Okay, let's put this one in first. Delta y we have, that is negative p. Delta x is the one that we need to find. So let's just put in the things that we have in hand first. So the dy by dx is actually negative 36 over 2x minus 5 raised up to the power 3. So negative 36, 2x minus 5 raised up to the power of 3. This is what we mean. I have the y value, but in this dy dx, we need to substitute the corresponding x value. So therefore, when y equals to 1, okay, so we have the function y is this, yeah? So 9 over 2x minus 5 squared equals to 1. Therefore, 2x minus 5 squared equals to 9. So 2x minus 5 will equals to plus minus 3. So 2x will equals to 5 plus minus 3. So we have two values of x here. Okay, so we have x equals to 8 over 2 or 2 over 2, which is 4 or 1. So we shall substitute this 4 or 1 into our equation here. So our objective is to find delta x. That means negative p times with 2x minus 5 cubed over negative 36 is approximately equivalent to delta x. So we change the position, yeah, so that delta x will be the subject. So the delta x will equivalent to p over 36. All right, and then we sub 4 in. We sub the 4 in. So this is when x equals to 4. The delta x will be 8 minus 5 cubed. So p over 36, 3 cubed, which is 27 over 36. So 27 over 36p, that give, after we simplify, we will have 3 over 4p. Okay, and on the other hand, when x equals to 1, the delta x will equals to p over 36. All right, and 2x, 2 times 1 is 2, so 2 minus 5 to the power of 3. So 2 minus 5 is negative 3. So negative 3, we raise up to the power of 3, we have negative 27. So we have negative 27 p over 36. Therefore, we have negative 3 over 4p. In short, delta x approximately equivalent to plus minus 3 over 4p. That's it for question number B, part 2. Now let us move on to C. So for C, we are given y equals to x to the power 4. And by using the calculus method, we got to find the approximate value of 2.03 to the power 4. Now this shows that if we let y, this is the new y, okay, is 2.03 to the power 4, that means the original y will be 2 to the power of 4. So from here, our x from 2 increased to 2.03. So there is very small changes in terms of x, that is 0.03. So if we want to find the value of the new y, we have to take the original y, okay, plus with the small changes in terms of y. So this is what we are supposed to do. So therefore, how do I find the delta y? So to find the delta y, so let's do it here. So to find the delta y over the delta x is approximately equivalent to dy by dx. This is the relationship between these two. So to find the delta y, it will be approximately equivalent to dy dx times with delta x. So dy dx is, we use the function of y. So 4x cubed times with the delta x. Okay, so in this case, the x that we are referring to is 2. So let's put the 2 in. So 2 to the power 3 times with the delta x. The delta x is 0.03. So over here, we have 32 times with 0.03. So that will be 0.96. Okay, and let's take the original y, that is 2 to the power 4, plus the delta y, which is 0.96. Therefore, 2 to the power 4 is 16. 16 plus 0.96, so we have 16.96. So this is the approximate value of 2.03 raised up to the power of 4. Okay, so this is question C, part 1. So likewise, okay, we can find part 2, 1.99 to the power 4. So the new y is equivalent to the 1.99 to the power 4, whereby again our original y is 2 to the power 4. So from here we know that x from 2 reduced to 1.99. Therefore, the very small changes in x is negative 0.01. Negative because it reduces, okay? Therefore, we want to find the delta y by the delta x, okay? In order for us to find the value of 1.99 to the power of 4, okay? So over here, I should write 2.03 to the power 4 up here. 2.03 to the power 4 is equivalent to 2 to the power 4 plus the small changes in terms of y, as there is a small changes in terms of x. So same thing goes to part 2. The new y is equivalent to the original y plus the delta y. So the new y that we are looking for is 1.99 to the power 4. It is it can be obtained by taking 2 to the power 4, all right, plus the corresponding delta y. So we've got to find what is delta y. So with that, delta y approximately equivalent to dy by dx times with delta x. So dy dx is 4x cubed, and the delta x here is negative 0.01. So the corresponding x value here, again, the original x, that is 2. Therefore, we will have negative 0.32. Okay, and therefore we plus a negative value of 0.32. So 16 minus 0.32, the answer will be 15.68. That's it. That's the answer for question part C and part 1 and part 2.